Hello, this is William from Visual Components. In this video, I'm going to show you how to teach a robot to grab multiple components. Now this can be very helpful if you want the robot to handle many components at one time. Now what I'm first going to do is show you how to build a simple layout and then go on to teaching the robot. If you don't want to do that, there's a link to the file you need in the video description as well as a time code you can jump to. Now to get started, make sure you have an empty layout in the 3D world. Next, go to the eCatalog panel, expand Models by Type, and then click Feeders. So we need to create a part that the robot can pick. So I'm going to add a basic feeder to the 3D world. And let's go here to the Component Properties panel and set Conveyor Width property to be 200, which changes the width of the feeder. Let's now add a conveyor. So go back to the eCatalog panel, expand Conveyors, click Visual Components, and let's add a type of conveyor that can form a batch or a couple of products that can be picked together. So in this case, I'll use this component called Batcher. So I'll just drag that into the 3D world and plug it into the feeder. Now notice the width of the batcher automatically changed because over here in the Component Properties panel I have this Automatic Parameters Enabled checkbox selected. So any matching properties this conveyor has with the feeder that I plugged it into, that will be changed. So notice here conveyor width is 200. Now the batch size of the components is controlled using this property called, yep, you guessed it, batch size. So the batch will consist of 3 components. And we have a couple other options. So after we get those 3 components and form that batch, we can delete them. We don't want to do that. We want the robot to pick them. So I'm going to clear this checkbox. And we can pack the batch to one component. And what that means is that you're merging all the components in the batch together so they move as one component. Now this can be very tricky if you're manually teaching a robot and you're depending on a batch ready signal. So I'm going to clear this checkbox for now. But if you are using like a controller component to automatically pick and place components, you may want to turn this on, but it depends on your scenario. But in this case, we're leaving it unchecked. We're throwing caution to the wind. So now if I run the simulation and just speed it up a bit, so notice the feeder creates these cylinders. So they have a radius of 50 and a height of 100. And now I have the 3 parts in the batch. So if I stop the simulation, there's 1 component, 2 component, and 3 component. Let's now add a robot and a gripper so we can kind of teach the robot to pick these parts. So I'll reset the simulation, go back to the eCatalog panel, and let's go here to Robots and expand it. And I'm working in the Models by Type collection. So under Robots, I'll click Visual Components, and I'm going to add this robot called Generic Articulated Robot version 3 to the 3D world. So let's drag that in. And let's just make sure the robot can reach the stack that we form here, or this batch on the conveyor. So just move the robot a bit closer. Let's now add a tool and mount it to the robot. So I'm going to go back to my eCatalog panel, and I actually will expand the Machine Tending Smart Collection here, and click Visual Components. And I'll just do a search for a tool. And it didn't find anything, so let's actually search for a gripper. And it actually did find this gripper here. So I'm going to use this parametric gripper. So I'll drag that into the 3D world, plug it into the robot. Now notice that our batch size consisted of 3 parts. So we don't need the suction gripper to be that big. We just need it to be 1 row of suction cups. So I'll stop the simulation. I have the tool selected. I'll go to the Component Properties panel here, and I'm going to change the suction cups Y property to be 1. So now I have 1 row with 3 suction cups. Good. So let's reset the simulation. And now we may want to place those parts somewhere else. So I need to add another feeder and conveyor to the other side of the robot. So I'll go back to the eCatalog panel, and I'll click Feeders again under Models by Type. And let's now add a shape feeder to the 3D world. So I'll just scroll down and use this component here. So I'll drag that into the 3D world. Let's go and change the view to top and move the feeder over there. And what type of part do we want to create with this shape feeder? Let's go here to the Component Properties panel, and we'll set the product to be a box. So we want to put those cylinders inside a box, and we want them to stop along a conveyor. So in this case, we should use some type of sensor conveyor so it can connect to the robot. I'll go back to the eCatalog panel, and under Models by Type, I'll expand Conveyors, click Visual Components, and let's just do a search for sensor conveyor. So I'll just type in sensor. And yep, it has this component here, so I'll drag a sensor conveyor into the 3D world and plug it into that feeder. Now it's a bit too close to the robot, so I'll hold down the Control key and add the shape feeder to the selection, and then I'll just move it over here. Great. Now that we have our layout built, it's time to program the robot. Now, if you know ahead of time that the robot needs to handle multiple components at a time, go ahead and select the robot as a component. Go to the Component Properties panel, click this tab here called Signal Actions, and notice you have a property here called Multi-Grasp. Go ahead and select that, and this indicates that when you're signaling a grasp or release action, the robot knows that, hey, detect multiple components, and if you find them, pick them. So make sure you turn this property on if you want to grasp multiple components. Let's now go to the Program tab, and let's go and program our robot. So I use the jog command to select the robot, and we first want to connect the robot to signals in the batcher conveyor and our sensor conveyor so it knows what's going on. So go here to the Show Group and select the Signals checkbox, and here's the inputs and outputs of the robot. So I want to connect a signal from the batcher conveyor as an input to the robot. So I'll expand the signal editor of this conveyor. I'll drag this red circle away from the editor to display a wire, and I'll then wire that connection to this in section in the robot. Let's change that in signal from 0 to be 50. So I'll just type in 50 here, and yep, there it is, and change it. So now the batch ready signal, when the batch in the conveyor is ready, it's going to signal the robot, and the robot will have that, will know that the batch is ready to be picked up. Likewise, we need to know when the box arrives at this sensor in the conveyor over here. So I'll expand the editor of the sensor conveyor, and we want to know that sensor signal, so that'll be an input to the robot. So I'll drag the red circle to display a wire, connect it to the in of the robot, and let's change that in signal from 0 to be 51, like so. And now when the box reaches this sensor, we want to stop the conveyor. So I'm going to change this start stop red circle. I'll drag it away to display a wire. And I want the robot to send out a signal to set that value. So it's going to set the start stop value. I'll change that from 0 signal to be 51, so we remember which component we're working with. So 50 will be reserved for the batcher conveyor, and 51 will be for the sensor conveyor. So now we have the robot wired up, so we don't need to see these anymore. I'll go back to the Show Group and clear the Signals checkbox. And let's now see how these signals work out. So go here to the Program Editor tab, the panel, excuse me. And what we first want to do is wait for our box. So in the main routine, I'll add a wait for binary input statement. And in the Statement Properties panel, we're waiting for that input signal from port 51. And we want to wait till the value is true. And then what we want to do is send out a signal. So I'll add a set binary output statement to the program. And we'll set signal 51, the signal connected to that port of 51, to be false. So I'm not going to check the checkbox here for output value. So let's see how this works out. So I'll run the simulation. And yep, notice that the robot stopped the box at that sensor. Now, you may be wondering why I'm not just jumping into teaching you how to grasp multiple components. It's always good practice to kind of go step by step and test along the way. So now that we know the robot will stop the box, let's now wait to check the signal that's received from the batcher conveyor in the robot that the batch is ready to be picked up. So I'll reset the simulation. I'll go back to the Program Editor panel. I'm going to add another wait for binary input statement. And we're waiting for a signal from the batcher conveyor, so that's to that signal port of 50. We want the input value to be true, so the batch is ready. And we're going to use the wait trigger checkbox here, so this will wait for a signal event. So the robot will evaluate the value of the signal connected to port 50. If it's true and it gets an event or update that the signal value has changed, then the robot will know, hey, the batch is ready. And let's see how this works. So I'll go back to the Program Editor panel. And let's go ahead and let's do something after we get that signal. So let's actually stop the simulation. So I'll add a halt statement. So what do we expect to happen? We expect the box to stop at the sensor conveyor. And after we get 3 cylinders here, the robot will get the signal and then the simulation will stop. So I'll run the simulation. The box stops. We have 1 part, 2 part, and at 3 parts, notice that the simulation was stopped. Great. Now that we know the signals are working, we now need to decide what tool frame in the robot we're going to use to pick and place these parts from this conveyor here and into this box. So with the robot selected, I'll go to the jog panel, and let's actually use base 1. And notice we have an imported tool frame from the gripper called Double Tool 1. So we can use that, but in order to signal an action for grasping a component, I don't want to have to configure any actions in the robot really. So what I'll do is I'll just use Tool 1, which is automatically set to perform a grasp and release action. So I'll set Tool 1. I'll click the gear icon to select it in the 3D world. And now I'm going to move tool 1 to where the imported tool frame is in the gripper. So to do that, I'm going to go to the 3D world toolbar, click frame types, and I'm going to turn on robot tools to show tool frames. So notice there's double tool 1. So I'm going to move tool 1 to that same location, so when I signal a grasp and release action, the robot knows to do that. So let's use the snap command here in the tools group. And I'll change the snap type to be frame or coordinate system, so I can snap to a frame in the 3D world. I'll click that double tool 1 frame there, and that's where tool 1 is. And I'll check the tool orientation by changing the coordinate system to object. So what I'm seeing now is the tool's coordinate system, and notice the z-axis is pointing in that direction, in the positive direction. We're now ready to teach the robot to pick and place multiple components. So what I recommend you doing is saving the layout, or you can just load the reference layout as needed. So I'm going to use the imported tool frame in the tool mounted to the robot. So in the jog panel, I'll set tool to be double tool 1, and I'll go ahead and start the simulation and just speed it up just a bit. So when the robot knows that the batch is ready, we'll then teach the position to pick this batch of parts. Alright, it's time for some action. So let's now snap the robot to this center point here. So we'll go to the tools group and click snap. And let's actually snap to the face center there. So the preview of the tool looks good, so I'll just click that point. Now the robot's at that location. So I'm going to actually teach this in a different subroutine in the program. So I'll go back to the program editor panel, click the plus sign to add our new sequence, and let's just rename this to be pick batch. And I'll teach this first position as a linear motion. I'll then use a set binary output statement, and let's go to the statement properties panel, and we're going to use signal action signal of 1, which is mapped to tool frame 1, and we're going to turn the output value on, so we'll select this checkbox so the robot knows to grasp something. And now let's go ahead and lift up. So let's teach an approach point and a retract point. So I'm using the tool's coordinate system right now, so what I'll do is in the z-axis I'll just add 100, and we're actually moving in the positive direction of the tool's coordinate system, so actually we'll take away 100 to move the robot back up, and let's take away another 100, and the robot moves up. So let's now teach that as a linear motion and a point-to-point motion, and let's do the point-to-point motion as the first statement in that routine. So the robot will go to the approach position, go down to pick up the parts, signal the grasp action, and then retract up. So let's actually call this routine now in our main routine. So I'm actually going to call it before the halt statement, so I'm going to insert it after the wait input here. So add a call sequence statement, go to the statement properties panel, and set that to equal pick batch. So if I reset the simulation, run again, let's see how this works out. So there's the third component. Robot goes in, and notice what happened. It picked up one component. Now you'll sometimes come across this situation, and what you need to do is you need to change the detection area of that signal action for grasping something, and I'll show you how to do that now. So what I'll do is I'll reset the simulation, and I'll now click the robot with the jog command to select the controller. And notice here in the controller properties panel you have this actions configuration section. Now you can select the robot as a component and you can still see this section. This is just another way of doing it. So I'll expand action configuration, and we're working with the output value of 1 with tool frame 1. Notice when signal value of 1 is true, it's going to grasp something, and when it's false, it will release something. Now when it's grasping something, it has this detection volume size, so it's going to detect a component and grasp a component that's within that volume space. Now we already set the robot to grasp multiple components, we just have to change the detection volume area, because you can see right here it's quite small, and we're using tool 1 to be the origin of where that volume space is being generated from. So what I'll do, I'll go ahead and go to the program editor panel, and I'm going to actually put the halt statement before I call that pick batch routine, and just run the simulation really quick to get the batch. So we have 2 components, 3 components, great. Let's now take a measurement to see how big we have to make the detection volume area to pick these 3 components. So I'll then do a measurement. So I'll go to the tools group, click measure, and let's actually measure from this edge point here to this edge point here. So actually we'll click free point here and just click that point there. and it's about 300 millimeters. So going from point 1, what I can do is I can have a cube or a rectangle that actually is going 150 millimeters that way and 150 millimeters that way, and it will detect all three of these parts. So to see how that works out, I'll close the measure tool. I'll go back to the controller properties by selecting the robot, like so. And for signal action, let's go back to the output of 1. And for the detection volume size, I'm going to change the x-axis because notice here, the tool position of the robot will actually be pointing downwards, and you can notice here from the robot position, you get an indication that the x-axis, its positive direction, is going in that way. So I'll change this to be 150. And if you want to be on the safe side, you could make this larger by typing in 300, but you might pick more than one component than you intend to. So it's always good practice to have your volume size just be as small as it needs to be. So if I set it to 150 along the x-axis, we should expect a length of 150 going that way, length of 150 going that way, length of 50 going that way and this way, and down to 50 along the z-axis. So if I reset the simulation, and let's now change where the halt statement is located in the routine. So I'll just drag that underneath the pick batch. Run the simulation and see how this works out. So here comes the third part. Come on, robot. Yeah! Alright, so notice the robot detected all three parts and grabbed them. And once again about the detection volume space, notice it's referencing the tool's coordinate system. So it goes down and creates this volume space to detect these three parts. What we want to do now is place these components in this box. So to do that, I'll go to the Program Editor panel. I'll add a new sequence, and let's rename this to be Place Batch. And now I want to move these components inside this box. So to do that quickly, I'll use the Align tool. So in the Tools group, I'll click Align. And now let's go ahead and snap the origin of one of these cylinders to the origin of the box. So here under the Align task pane, Snap Type, I'll click Origin. And let's actually use the origin of the middle cylinder here. So I'll click there. And now let's go ahead and select the origin of the box so we can see the preview. So far it looks good, and the robot snaps there. But I do think that there's a distance from the origin of the box to this face here. So I'll do a quick measurement. I'll go to the Tools group, click Measure, and let's measure from the origin of the box to this face here. And it's a difference of about 10 millimeters. So what I'll do is I'll go close out of the Measure tool, go to the Jog command, and I'm going to work in the Tools coordinate system. So I'll set the coordinate system to the object here, and we're going to move back 10 millimeters. So I'll do minus 10. Notice the robot moves up, and that looks good. But it seems that the mounted tool of the robot is colliding with the inside of the box. So let's actually rotate the tool a bit. So here in the Jog panel, I'll set RZ to be 90. And that looks good. Yep, we have enough space. Let's now teach this as a linear motion. So in the Place Batch routine, I'll add a linear motion statement, and then add a set binary output statement. And in the Statement Properties panel, we're using Signal 1 and Toolframe 1 to signal the release action, so output value in this case is going to be false. Let's now teach a retract and approach position, so I'll just move the robot up. That looks good. So let's teach that as a linear motion and a point-to-point motion. And we want our point-to-point motion to be first, so the robot will just move to that approach position, go down, release the components, and move back up. Let's now call the Place Batch routine in our main routine. So I'll click the main routine here. And after we do the call to the Pick Batch routine, let's call the Place Batch routine. And we want to turn the sensor conveyor back on. So I'll go ahead and add a set binary output statement. And remember, sensor conveyor was using port 51. So we're going to set the output value, the signal connected to port 51, to be true. So the start-stop signal in the sensor conveyor will turn the path back on. And let's actually get rid of the halt statement. So I'll select it here in the statements list and press the delete key. And let's reset the simulation and see how this works out. Now there is one thing I want to show you, so I know an error will happen. I just want to let it work its way through. So we're waiting for the batch. The robot picks up the parts. He places them in the box. So far so good. And whoa, wow, whoa, wee, whoa. Look what happened. So the robot released the components, but they weren't actually released to the box. They're not contained in it. So now the cylinders and the box are moving separately. And why did that happen? Well, I'll show you. So I'll reset the simulation, In the program editor panel, I'm going to go back to the place batch routine. And after the robot, let's see, the robot goes down to place the part. Let's actually add a halt statement. So I'll run the simulation and just speed it up real quick. So the robot goes there. All right. Now, what happens here is that when you're releasing a component, the robot is using what's called a gravity direction. And what I'll do is I actually will directly select the box here and just hide it for now. So when you're using a gravity direction, what happens is that the components that are attached to the robot at this tool frame, they're then moved down a certain distance, and then that distance where the components are, they're used for a collision detection test. And whatever those components collide with, that's going to be what they're attached to. Otherwise, there's another setting in the robot that I can talk about briefly. So what I'll do is I'll go back to the Home tab, and I'm going to select the robot now. I'm going to go here to the Component Properties panel and click Signal Actions. Now, when you want to release a component directly to the world, you can just turn on this checkbox here. It will be released to the world. But when you're using signal actions, you have to be careful with your gravity direction. So I'll set output to be 1. And notice here when you're releasing, you have this property called gravity direction. So what that means is that the components will be moved down in the positive direction of the tool's coordinate system in this distance, and whatever those components collide with, that will then be what they're attached to. So to demonstrate, I'll select one of these cylinders, and now in its coordinate system, I'm going to move it down. Assuming it's the tool's coordinate system, I'm going to move it down 25 millimeters, so minus 25. That's where the component will move to during the test. It's not actually going to move at 25 permanently. And whatever this component collides with, that's when it's going to be attached to. So notice here that the cylinder is colliding with the conveyor. So that's why this cylinder was attached to the conveyor, not the box. So if I actually make the box visible again, I'll go to the cell graph panel, and under products, it actually was a dynamic component, sorry, so I actually will have to reset the simulation. And select the box, and let's stop the simulation. So let's actually take a measurement. Well, we really don't need to, because we know that we're placing the cylinders right on this face of the box. So our gravity direction, doesn't need to be 25, it could just be 1 millimeter. So I'll select the robot again as a component. And actually, let's reset the simulation afterwards. And for the signal actions here in the Component Properties panel, I'll go back to my signal action of 1. And let's now set gravity direction to be just 1, because the cylinders are touching the top face of the box that's inside it. So now if I go back to the Program tab, and let's actually change the state of the robot, because I actually started this simulation when the robot was here, so it saved this joint configuration of the robot. So I'll go to the jog panel and just set it back to its normal set. Oof, that's not normal, sorry. So J2 should be 0, J3 should be 90, and all the other ones can be 0, like so. So now if I want to save that state, I'll go to my simulation settings and click this command here called Save State. And when I start the simulation, notice the robot starts in that joint configuration. So let's slow this down. And now the robot goes into strike. And I had that halt statement, so I'm going to continue with the simulation. Notice I'm not resetting it, I'm just continuing the simulation. And now notice the parts do move with the box. Great. Now this does conclude the video. If you have any more questions, please feel free to visit our forum at forum.visualcomponents.com. And I will be continuing other videos with this same layout. For example, I'm going to show you how to use robot variables to create loops and if and else conditions. I'll also show you how to create layers when you're picking and placing parts by changing, base frames and tool frames. So stay tuned, and as always, have a wonderful day.